Let's say we are given a statement that says an object with a mass of 10 kg is placed in a horizontal surface. Force of 50 Newton is applied to the right at an angle of 30 degrees as shown in the diagram below. So here's our diagram. We have a box of 10 kg. We have a force of 50 Newton. We have an angle of 30 degrees. So this is our surface, as you can see. So the first question is draw a free body diagram showing all the forces acting on the object. Since always when they ask you for a free body diagram, always look at the marks first. If it's 2 marks, that means you're gonna have to show only 2 forces acting on the object. If it's 3 marks, that means you're gonna have to show 3 forces. If it's 4 marks, that means you're gonna have to show 4 forces. So this is 4 marks. That means we're gonna have to show 4 forces acting on that object. So we're gonna say free body diagram number 1. Since I'm gonna have to draw 2 free body diagrams, but I'm gonna advise you to take the second one because the second one is perfectly clear to show you how to calculate. Because remember, always a free body diagram helps you on your calculations. So I'm gonna draw first the free body diagram here. This dot is representing our box. So we have this force going up. We have this force going down. They are both perpendicular to the surface since it's a horizontal surface. And we have this force going opposite to our motion. Then we have this force acting at an angle. So since we have 4 forces acting on the object, this force we call it a normal force. We call it a normal force. Normal force is always perpendicular to the surface, so it always goes with this force. Call it G, which is a force, your gravitational force. This one is perpendicular because it's always perpendicular to the surface. So we have this force always opposite our motion. We call this force Fk. Why Fk? Is a kinetic frictional force. Remember, we have 2 frictional forces. We have kinetic frictional force and a static frictional force. So a kinetic frictional force is the force that opposes the motion of a moving object, and a static frictional force is the force that opposes the motion of a stationary object. So since it is moving, we call this force kinetic frictional force. So this force at that angle, we call it F, or we can call it Fa. It's up to you how you wanna name it. So is 4 marks. So we have 4 forces: normal force, kinetic frictional force, G, and F applied, or F, it depends. So free body diagram number 2, I'm going to put here. This is very important. I'm gonna make this dot bigger, a little bit bigger, because I'm gonna show some more forces. So, okay, since we have this force going upwards, we call it the normal force. We have this force going down, we call it an G, or weight. We have this force going this way, we call it K. Then, since there is this thing at angle, this force we can write it this way: 2 components. You can give it 2 components, or name it. Let's acting this way. This is our force acting at an angle. So we can say this one is Fy. Why Fy? Because it's a vertical component, and we can call it this one Fx, since it's a horizontal. So this force can be presented in this way: Fy and Fx, vertical component and horizontal component. So we're gonna write this way. That force, we're gonna write it since that force is going up. We have this force and this one. So remember, these are 4 forces, not. So since we put this one Fg, same as that one, Fg perpendicular, we call this one normal force, we call this one Fk as kinetic frictional force. Then we call this one Fy, a vertical component, and we call this one Fx. So why am I saying these are 4 forces? 1, 2, 3, 4. So when we mark, we're gonna say, I'm gonna give you 1 mark here, 1 mark here, 1 mark here, 1 mark here, on this free body diagram. So what about this one? This one I'm gonna give you 1 here, 1 here. So since this is 1 force, but it represented in 2 dimensions, so we call it a 2-dimensional force. So give it 1 mark because 2-dimensional force, but it's a 1 force, but in 2 dimensions. So it's 1 mark, this one. So we call it 1 force. And remember, no additional force. Once you add any force that is not on the object or on the motion, it's subject to 1 mark. So let's say question 2 says calculate the normal force. Calculate the normal force on the object. So remember, a free body diagram helps you on how to calculate. So that's body diagram number 1. This free body diagram is not gonna help you on your calculations. Never. But let's look at free body diagram number 2. Free body diagram number 2, it clearly shows which forces are going this way, which forces are going this way. So let's check for normal force. Let's go to 2. We should calculate normal force. So since normal force is the force that is going upward, that means we're gonna focus on vertical forces, no horizontal forces that are involved. We focus on vertical forces only. So let's check how many forces are going upward. How many forces are going up? So we have this force, normal force, and Fy. So we have normal force plus Fy. We add them since going up together. They are going at the same direction. So it's equal to there are 2. So how many forces are going down? It's only 1. It's G. So N plus Fy equal to Fg. So let's not forget that Fg is equal to mg. Since mg is a mass, it's a mass multiplied by gravitation acceleration, which is 9.8. So let's not forget that Fy is equal to F is Y with sine that given in. Okay, since we're looking for normal force, so here is our normal force plus, what is Fy? Oh, okay, let me do this. Let me do it this way. One, since it's Fy, and we know Fy is F sine theta, Fg is mg. So we're gonna do it this way. I want to make normal force the subject of the formula. Then I'm gonna take Fy and join Fg. Then let me go straight. Let us not waste the time. So okay. So let me say N is equal to Fg minus Fy to this side is going to be minus Fy. So it's normal force equal to Fg, so it's mg minus Fy is F F sin theta. So replacing them. So we have N is equal to, what is mg? M is the mass of an object, which is 10. That object is 10 kg. What about G? G is our gravitational acceleration, which is the constant, 1.8 meters per second squared, minus F. F is our force, is our applied force, which is 50 Newton. So it's 50. What is our angle? Sine angle, which is 30 degrees. So what is 10 multiplied by 9.8? That is gonna be 98. 98 minus, what is 50 sine 30? Remember sine 30. Okay, let me write it here. Remember sine 30. Remember this triangle. By 10, I think. Let's see. 30 degrees. This one is 60 degrees. This one is 2. This one, oh, so 3. This one is 1. So sine 30 is opposite over hypotenuse. So it's 1 all over 1 all over 2. So it's 1/2. So 50 times 1/2 is 25. That means it's 50 divided by 2. So it's 25. So 98 minus 25. That is gonna give us 73 Newton. So that means our normal force is 73 Newton. So that is the end of our discussion. Thank you for watching, and please subscribe. I am begging you, please subscribe.